So everybody, let's begin our discussion over the questions. The first question coming up says that in the given figure, so the figure is given to you, if TP and TQ are two tangents to a circle with center O so that angle POQ is 110 degrees, find the measure of angle PTQ. This is the angle whose measure I need to find. Now in this figure, the moment they are saying that PT is a tangent, TQ is a tangent, you all know that the radius of the circle is perpendicular to the tangent through the point of contact, and therefore both these angles are 90 degrees each. This is 90 degrees, this is 90 degrees, and the reason is what? That the radius of the circle is perpendicular to the tangent through the point of contact. The point of contact means point of tangency is point P, and so OP will be perpendicular to PT. Similarly, OQ will be perpendicular to TQ because the point of tangency of this tangent TQ is point Q. The moment I have 3 angles out of the 4 angles of the quadrilateral PTQO, I know by angle sum property of quadrilateral PTQO, I will have angle PTQ plus angle OPT plus angle POQ plus angle OQT is 360. Clear? Out of this you don't know. OPT 90, POQ is given as 110 and this is also 90. So 110 plus 90 is 200, 200 plus 90 is 290, 360 minus 290 is what? 70. Fine, and so angle PTQ's measure is 70 degrees. Now that I have this, let's move on to the next question. Obviously option number B would be the correct one. Next, let's see the question is what? It says that the length of a tangent from point A, which is sitting at a distance of 5 centimeters from the center of a circle. So, okay, this is a circle. Center of the circle is O, suppose. From the center of the circle, a point A is sitting at a distance of 5 centimeters. So, say this is the point A, sitting at a distance of 5 centimeters from the center of the circle, and the length of the tangent from point A to this circle is 4 centimeters. So when you draw a tangent passing through this point to this particular circle, then if this is the point of tangency, say T, then from this point A to point T, this is the length of this tangent given to you as 4 centimeters. It is asking us to find the radius of the circle. I know that if I join O with T, this is the radius. OT is actually my radius. What is its measure is what the question is trying to ask. The moment this is my tangent line, I know the radius is perpendicular to the tangent through the point of contact, and so this makes triangle OTA a right angled triangle in which I can say hypotenuse square is equals to base square plus perpendicular square. So I will have 5 square equals OT square plus TA square. So this is 25 equals OT square plus 4 square. So you have 25 minus 16, that is 9 is OT square. So OT is 3 centimeters. OT is nothing but your radius. So radius of the circle is 3 centimeters. Clear? Moving to the next question, it says that if these two tangents are there from a point P to a circle with center O and they are inclined with each other at an angle of 80 degrees. So what is the situation? Say this is the circle centered at O. From an external point P, two tangents are drawn. One is this and one is this. Say this point is A and this point is B. So PA and PB are two tangents drawn from an external point P to the circle centered at O. they are inclined to each other at an angle of 80 degrees, that means this angle is given to you as 80 degrees. They are inclined to each other at an angle of 80 degrees, that means the angle which these two tangents are forming is 80 degrees. Angle POA, I am supposed to find this angle. Okay. Now just like you joined O with A, join O with B as well. We have already done this, as I have been saying this in the past two questions also, that the radius of a circle is perpendicular to the tangent through the point of contact. This is 90 degrees. Similarly, this is also 90 degrees. Right? Here, what is happening is that if this is 90 degrees, this is 80 degrees, this is 90 degrees, then this complete angle, if you consider, if you remember, we have done this result that two tangents drawn from an external point subtend equal angles at the center. So you have this angle exactly equal to the other half. So angle POA is half of angle PBO, or I should say BOA. What am I saying? Angle POA is half of angle BOA. Angle POB is half of angle BOA. So we have this, and if you are not able to recall it, you can very easily prove. In triangle POA and in triangle POB, you know that PO is equal to PO, that is common. PA is equal to PB. Why? Because the length of the tangents drawn from an external point are equal, and this is 90 degrees, this is 90 degrees. So by RHS congruence condition, you have this angle is equal to this angle, right? So you have angle POA is same as angle POB, and both are, if they are equal to half of angle BOA. Is it clear? Or I can say angle BOA is twice of angle POA, or angle BOA is twice of angle POB, anything you can write. Now if you consider AOBP, this is a quadrilateral, sum of whose angles is 360. So you have 80 degrees plus 90 degrees plus 90 degrees plus angle BOA is 360 degrees by angle sum property of a quadrilateral. This is 180. 180 plus 80 gives you 260. 360 minus 260 gives you 100. And angle BOA is twice of angle POA. So angle POA happens to be 100 upon 2, which is 50 degrees. So the measure of this much angle is 50 degrees. Is it clear? You can directly use the result also that two tangents drawn from an external point to a circle subtend equal angles at the center. We have proved it in our theory lectures. Now that we are through with this, let's take a look at the next question. Obviously over here, your correct answer is option number A, that is 50 degrees. So next question says that two concentric circles are there of radius 5 centimeters and of radius 3 centimeters. So obviously the circle with radius 3 centimeters is sitting inside the circle of radius 5 centimeters. Both have the same center. So this is, say this is one circle and say this is another circle, both having the same center. I have to find the length of the chord of the larger circle which touches the smaller circle. So just make a chord of a larger circle which is touching the smaller circle. Say this is A, this is B, it is touching the smaller circle over here, say this is C. I have to find the length of this chord AB. Fine. Now see, this is the center of the larger circle as well as the center of the smaller circle. If I join this over here, you can clearly see right now, if you only look at the smaller circle and the AB chord, then AB is actually acting as a tangent to the smaller circle because it is only touching the circle at one point C. So the point of tangency is C, right? And AB happens to be tangent to the smaller circle. And therefore, this OC, say this is O, then OC is the radius of the smaller circle, and I know that the radius is perpendicular to the tangent to the point of contact. So angle OCB happens to be 90 degrees. Now change your perspective. Now look at AB as a chord of the bigger circle whose center is O. Both the circles have same center. And I know that if OC is perpendicular to AB, I know that AB is a chord of the bigger circle and center is O, perpendicular from the center to the chord bisects the chord. Using these two results, I have AC is same as CB and I have OC is perpendicular to AB. Clear? Now you join O with B. If AC is same as AB, both are equal, they are equal to half of complete AB because AB is bisected into two halves. So each part is half of AB. Or I can say AB is twice of BC or twice of AC, anything, because AC is same as BC. Now if you join this, you know that this thing OC is the radius of the smaller circle which is given as 3 centimeters. OB is the radius of the bigger circle which is given as 5 centimeters. And this is a right angle triangle, so you have OB square equals OC square plus BC square. OB square is 5 square which is 25, OC square is 3 square which is 9 plus BC square. So BC square is 16 which implies BC is 4. The moment BC comes out to be of 4 centimeters, AC is also of 4 centimeters. Why? Because AC is same as BC and therefore AB's length is 4 plus 4, that is 8 centimeters, or you can directly from here compute AB, which is twice of 4 centimeters, which is 8 centimeters. So the length of the chord of the larger circle which touches the smaller circle when the two are concentric is 8 centimeters in this scenario. Let's take a look at the next question. It says that two tangents TP and TQ are drawn to a circle with center O from an external point T. This time the external point is a point T. The circle is there with center O. The external point is point T, say, and there are two tangents drawn. One is this and another is this, TP and TQ. With center O from an external point T, prove that angle PTQ, this angle, is twice of angle OPQ. So if you join PQ, and this is O to P, so this is OPQ. I have to show angle PTQ is twice of angle OPQ. I have to show this. Now try to recall, these are two tangents drawn from an external point, so their lengths are equal, right? If PT is same as QT, because tangents drawn from an external point are equal in length, focus upon this triangle, which is this triangle PTQ. If you focus upon this triangle, two sides of this triangle are equal and angles opposite to equal sides are equal, so this angle is same as this angle. Suppose the measure of this angle is x. This angle is same as this angle, both will be equal to x. Now in this triangle, by angle sum property, angle PTQ is equal, or I should say angle PTQ plus angle TPQ plus angle TQP is 180. Let this remain as it is. This is x and this is x because both are equal in measure. Angles opposite to equal sides are equal. So you have angle PTQ plus 2x is 180. Right? So what you have? 2x is 180 minus angle PTQ, or x is 180 upon 2 minus angle PTQ upon 2. So x is 90 minus half of angle PTQ. This is x. Now focus upon one more thing. OP is the radius of the circle and TP is the tangent. Radius is perpendicular to the tangent through the point of contact. So this complete angle is 90 degrees. This complete angle is 90 degrees. OP is perpendicular to TP. And therefore you get angle OPT is 90 degrees. Now angle OPT can be written as OPQ plus QPT. angle OPQ plus QPT is 90 degrees. So angle OPQ is 90 degrees minus angle QPT, but angle QPT is X. Angle QPT is X. So this is 90 degrees minus X. But what is X? X is 90 minus half of PTQ. So it is 90 minus half of PTQ, which is 90 minus 90 plus half of PTQ. What do you get? You get twice of angle OPQ is angle PTQ. And that is what you had to show. Let's move on to the next question. It says that prove that the parallelogram circumscribing a circle is a rhombus. That means if there is a parallelogram containing a circle, then that parallelogram has to be a rhombus. How do you show this? So you have a parallelogram. Okay, it is circumscribing within itself, say this circle. It is circumscribing within itself this circle. Say the circle is centered at O. This is A, this is B, this is C, this is D. The moment I am saying it's a parallelogram, I already know that AB is same as CD and AD is same as BC. Because opposite sides in a parallelogram are equal in length. They are not just, opposite sides are not just parallel to each other, they are also equal in length. So length of AB is same as length of CD, length of AD is same as length of BC. Because it is already a parallelogram, I know that opposite sides are parallel. A parallelogram in which all four sides have same measure is a rhombus. So I need to show that all four sides have same measure. Till now I know that opposite sides have same measure. I need to show that all four sides have same measure. How will I do that? Now see, let me mark these points as P, Q, R and S where the circle is touching the parallelogram. If you focus upon point C, you can see that CQ and CP are two tangents drawn from an external point C to this circle centered at O, and therefore the length of the tangents drawn from an external point to a circle are equal in length, and so CQ is same as CP. Again, look at point B. BR and BQ are nothing but tangents drawn from an external point B to this circle, and so they will also be equal in length. So you will have BR equals BQ. Again point A, if you perceive, from point A, AR and AS are two tangents drawn from this external point A to this circle. So even they will be equal in length. So AR will be same as AS. Similarly from point D, D is an external point. When you draw two tangents, DP and DS, they will be equal in length. So you will have DS is same as DP. This we have got on the basis of the fact that lengths of tangents drawn from an external point are equal. So therefore, now if I consider DP plus PC plus AR plus AB, what are you getting? DP is same as DS, PC is same as CQ, AR is same as AS, and AB, what is AB? Here I took AR plus RB, not AB, RB. So RB is same as BQ. This you will be getting. DP plus PC, DP plus PC is DC, AR plus RB is AB. DS plus CQ plus AS plus BQ. So DS plus AS DS plus AS is DA or AD, and CQ plus QB is BC. DC plus AB you have got same as AD plus BC, but you already know that AB is same as CD. So in place of CD I can write AB again, AB, and over here AD is same as BC, so in place of AD I can again write BC by 1. So you have twice of AB is twice of BC, 2 cancels out, AB is same as BC. You are getting AB is same as BC. But AB was equal to CD because opposite sides are equal in a parallelogram. AB was actually equal to CD and BC was actually equal to AD. And so you are getting that all the 4 sides are equal in measure, equal in length. And therefore this parallelogram in which all 4 sides are equal is now a rhombus. Next question says, prove that the tangents drawn at the ends of a diameter of a circle are actually parallel to each other. Let's prove this. Pretty interesting statement. It says that if you have a circle, okay, and you take a diameter, so this is A, this is B, then with A as the point of tangency and B as the point of tangency, if you draw 2 tangents to this circle, then they will be parallel. So I have to show L1 and L2 are parallel. Fine, this is the center. Now this is pretty interesting question. Why? Because it is going to make you revise your previous concepts as well. From the center, if I talk about this segment OB which is drawn from the center to point B, this is nothing but the radius, right? And you know that the radius is perpendicular to the tangent through the point of contact. Similarly, OA will be perpendicular to the tangent through the point of contact. So if I take here say some point R and if I take here some point S just for convenience, I have angle RAO is equal to angle OBS, which is 90 degrees, isn't it? Because the situation is like this, there are 2 lines and this is like a transversal. This angle is equal to this angle. This is also 90 degrees, this is also 90 degrees. So this is what? This is actually a pair of alternate interior angles are equal, which is a pair of alternate interior angles. And the moment there are 2 lines being intersected by a transversal, making one pair of opposite interior angles or alternate interior angles equal, means that these 2 lines are parallel. So these 2 lines, that is L1, will be parallel to L2. Fine. And L1 and L2 are not just 2 lines, but actually they are tangents drawn at the ends of the diameter of the circle. So that means that the tangents drawn at the ends of the diameter of a circle are actually parallel to each other. Next question says that PQ is a chord of length 8 centimeters of a circle of radius 5 centimeters. The tangents at P and Q intersect at a point T. Find the length TP. Before we talk about the length of the segment TP, focus upon the 2 triangles PRT and QRT. Okay. You all know that OP is the radius, or let me not talk about it right now. If you focus upon angle RTP and RTQ, you know that TP is same as TQ because from an external point, when you draw 2 tangents, they are equal in length. TP is common. TP is common to both the triangles, and if you remember this theorem, that when 2 tangents are drawn from an external point, they are equally inclined with the line segment joining the external point with the center. So this angle is also same as this angle, which says that by SAS congruence rule, these 2 triangles are congruent. So what do I say? I am saying PT is same as QT, because length of tangents drawn from an external point to the circle are equal in length. Then TR is same as TR, and I have angle QTR is same as angle PTR, because the two tangents drawn from an external point to a circle are equally inclined with the line segment joining that external point with the center. So these angles will be equal, and therefore by SAS congruence rule, I will have triangle RPT congruent to triangle RQT. And therefore by CPCT their corresponding paths will be equal. So you will have RP is same as RQ by CPCT. So you have this RP segment is same as RQ segment. The moment RP is same as RQ, R is the midpoint of the segment PQ. If R is the midpoint, that means PR is half of PQ, RP is half of PQ. So both are equal to half of PQ, but PQ is of 8 centimeters. So they both are equal to half of 8, which is 4 centimeters. So I have PR is of 4 centimeters, RQ is of 4 centimeters. Now the moment R is the midpoint of PQ, what is OR? What is OR? PQ is actually acting as a chord of this entire circle, right? And you know that a line which is drawn from the center to a chord which is bisecting the chord is actually perpendicular to the chord. Right now if I talk about the line joining O to R, because R is the midpoint, OR is actually bisecting the chord PQ and is drawn from the center to the chord, so it will be perpendicular to the chord. So OR is also perpendicular to PQ. Why? Because a line drawn from the center to the chord, which bisects the chord is perpendicular to the chord. Clear? Line which is drawn from the center to the chord which bisects the chord has to be perpendicular to the chord. This is the converse of the statement that perpendicular drawn from the center to the chord bisects the chord. Now you have this angle is of 90 degrees. Focus now upon PRO triangle. In triangle PRO, the moment I have this angle as 90 degrees, this is a right angle triangle. So I have PO square is equals to PR square plus RO square. So you have PO square is PR square plus RO square. PO square is 5 square, which is 25. PR is 4 centimeters, so PR square is 16 plus RO square. So RO square is 9, RO is 3. So you have RO of 3 centimeters. Now, if you can very clearly see, I wish to find the length of TP. I know TP's length is same as TQ, so that's okay. I wish to find the length of TP. Don't forget OP is perpendicular to this tangent TP because the radius is perpendicular to the tangent through the point of contact. So right now if I take TP as X and TR as Y, what do I get? Let TP be X and TR be Y centimeters. Then I have two right triangles with me before me. One is right triangle PTR. So in triangle PTR, you have hypotenuse square is equals to base square plus perpendicular square. So x square is equals to y square plus PR square. PR is 4. So x square is equals to y square plus 4 square. 4 square is 16, and another right angled triangle is what? Because OP is perpendicular to TP, so OPT is another right angled triangle. OPT is another right angled triangle, so hypotenuse will be OT. What is the length of OT? OT is TR plus RO. TR is Y, RO is 3, so Y plus 3. So y plus 3 square. So hypotenuse is y plus 3. Hypotenuse square is equals to base square plus perpendicular square, 5 square plus x square. This is 5 square plus x square, but x square by this equation is y square plus 16. So you have 25 plus y square plus 16. This will be y square plus 9 plus 6y. Y square cancels out. What is this? 25 plus 16 gives you 41. This is 6y equals 41 minus 9. This is 32. Y is 32 upon 6, which is 16 upon 3. Y is 16 upon 3, so what is x? 16 upon 3, this is 16 into 16 upon 3 into 3 is 9 plus 16. So 16 comes out common, you have 16 upon 9 plus 1. This is 16 into 25 upon 9. This is the value of x square. If this is the value of x square, what is x? Square root of this is square root of 16 into square root of 5 upon square root of 9. So this gives you 20 upon 3. X is 20 upon 3. X is the measure of PT. So PT is, or TP is 20 upon 3. Next says, prove that opposite sides of a quadrilateral circumscribing a circle subtend supplementary angles at the center of the circle. What do I mean by this? First of all, there is a quadrilateral circumscribing a circle. So say that's the figure. This quadrilateral is actually circumscribing a circle. So say this quadrilateral is actually circumscribing a circle. That means this quadrilateral is containing this circle. So say this is P, this is Q, this is R, this is S, this is A, B, C, D. First of all, if this is the center of the circle, you all know that AD is a tangent to this circle, so OP will be perpendicular to AD because radius is perpendicular to tangent through the point of contact. AB is also tangent to the circle, point of tangency is Q, so this is also perpendicular to the tangent completely. After that you have what? This is OR if you join. Then BC is actually the tangent to this circle. If BC is a tangent to this circle, then OR is the radius, and radius is perpendicular to the tangent through the point of contact. So OR will also be perpendicular to BC. Clear? Similarly, OS will be perpendicular to CD because CD is also a tangent to the same circle, and radius is perpendicular to the tangent through the point of tangency or the point of contact. Now what you do is, you draw these lines joining the center with the vertices of the quadrilateral. Focus upon the two triangles POD and SOD. You all know that DP and DS are two tangents drawn from an external point D, and so they will be equal in length. Moreover, OP is same as OS because both are radius, and OD is equal to OD because this is a common side in both the triangles OPD and OSD, and therefore by SSS congruence rule both the triangles will be congruent, and so this angle, angle 1, will be equal to this angle, angle 2. What did I say? I said PD is same as SD because tangents drawn from an external point are equal in length. Then OP is same as OS because it is equal to the radius, and I am saying OD is same as OD. It's the common side, and therefore by SSS congruence rule, triangle POD is congruent to triangle SOD. Therefore by CPCT, angle POD is equal to angle SOD. So you have 1 is equal to 2. Similarly, if you talk about POA triangle and QOA triangle, again AP will be equal to AQ. Why AP will be equal to AQ? Because tangents drawn from an external point to a circle are equal in length. Moreover, OQ will be same as OP. again radius, and OA is the common side. So these two triangles by SSS congruence rule will be congruent, and so this will be equal to this. So you will have angle 3 is equal to angle 4. Similarly, 3 is equal to 4. This is happening by CPCT. Similarly, 3 is equal to 4 when you prove these two triangles are congruent. Exactly in a similar fashion, you will have 5 is equal to 6 when you prove these two triangles QOB and ROB are congruent, again by SSS congruence rule, because you will have QB is same as BR, tangents drawn from an external point to the circle are equal. Then OR is same as OQ because it is the radius, and OB is the common side. Similarly here, CR will be same as CS, tangents drawn from an external point to the circle are equal. Again, OR will be same as OS because it is equal to the radius, and OC is the common side. So these two triangles will also be congruent. So you will have 7 is also equal to 8. So you will have 5 is equal to 6, 7 is equal to 8. I have to show that the opposite sides subtend equal angles at the center. AD and BC are opposite sides. They are subtending equal angles. I have to show, means I have to show angle AOD is same as angle BOC. Similarly, AB and CD are opposite sides. They should subtend equal angles at the center, means I have to show AOB is equal to angle DOC. Now, how do I prove this? If I consider 1 plus 3 plus 6 plus 7, 1 plus 3 plus 6 plus 7 plus 4 plus 5 plus 2 plus 8, everything I am adding. Actually, I am adding all the angles, 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8. I am adding all the angles. Why I am adding? This is 8. I know that this is representing the angle at the point O. An angle at a point completely is of 360 degree measure. So this is 360 degrees. But 1 is same as 2. 1 is same as 2, so I will be writing twice of 1. Then you have 3 is same as, 1 is same as 2, 3 is same as 4, 3 is same as 4, so I will be writing twice of 3. 6 is same as 5, so I will be writing twice of 6. 7 is same as 8, so I will be writing twice of 7. Fine. So you have 1 plus 3 plus 6 plus 7 is 360 upon 2, which is 180. 1 plus 3 is angle AOD, and 6 plus 7 is angle BOC. You have proved that angle AOD plus angle BOC is 180. That means you have shown that the angles subtended by the opposite sides at the center are supplementary. Exactly in the same fashion, you can show that the sum of the other two angles is also 180. How? Because you know that this complete is 360. If these two angles are 180, you know that angle AOD plus angle DOC plus angle BOC plus angle BOA. This is 360. This is same as this only. Angle around a point is 360. So AOD plus BOC is 180. So BOA plus DOC is 360 minus 180, which is 180. And so this and this in the combined way shows you that if I talk about these two opposite sides, AOD plus BOC is 180. That means these angles are subtending, or these opposite sides are subtending equal angles at the center, and AOB and DOC, their sum is also 180. That means these two opposite sides are also subtending equal angles at the center. Let's move on to the next question. In this figure, what are we given? Two parallel tangents are given to us. Okay. So two parallel tangents are given to us, and another tangent AB with the point of contact C is also given to us. Prove that AOB is 90 degrees. What I will do is I will join O with C. The moment I join O with C, I know OC is the radius of the circle, and radius is perpendicular to the tangent through the point of contact. AB is the tangent, so OC will be perpendicular to AB. Moreover, OP will be perpendicular to xy because OP is also the radius and xy is the tangent. Similarly, OQ will be perpendicular to x dash y dash because OQ is the radius and x dash y dash is the tangent. So, I will have OP is perpendicular to xy and OQ is perpendicular to x dash y dash. Exact same reason that the radius is perpendicular to the tangent through the point of contact. Now, focus on these two triangles. If you focus on these two triangles, you have AP is same as AC because from this external point A, I am having two tangents drawn, so they will be equal in length. AP is same as AC. Then you have OP is same as OC, both are equal to the radius. And you have OY is same as, or OA is same as OA because it is the common line in both the triangles. So, by SSS congruence rule, I have triangle OPA is congruent to triangle OCA. Triangle OCA. And therefore, angle POA is equal to angle COA by CPCT. So, you will have this angle is same as this angle by CPCT. So, 1 is same as 2. So, this implies 1 is equal to 2. Exactly on the similar lines, you can show these two triangles are also congruent. How? BQ is same as BC because tangents drawn from an external point B to the circle are equal in length. After that, you have OB is same as OB, it is the common side, and OQ is same as OC because it is equal to the radius. So, again by SSS congruence condition, these two angles will be equal. So, 3 will be equal to 4. Similarly, 3 is equal to 4. Fine. Now, you all know that if I add 1 plus 2 plus 3 plus 4, I get angle on a straight line PQ. So, it is of measure 180 degrees. So, I have 1 plus 2 plus 3 plus 4 is 180, right, but 2 is same as 1. So, I write 2 plus 2 and 3 is same as 4. So, I write this. So, you have twice of 2 plus 3 is 180. So, you have 2 plus 3 is 90, but 2 plus 3 is nothing but angle AOB. So, this is 90. Is it clear? That is how you apply your basic results which we have learnt in theory in all these questions to get their answers. That is it from my side. Thank you.